All right, everybody. Welcome to our second walkthrough for our second staff choice project, this one on Android. So today we'll be going over NPuzzle and some of the things you'll need to implement that. So just reminders, all these guys are posted online. The walkthroughs are separate from the section videos, as we had a couple questions about that. So when you actually look at the projects page, that's where the walkthrough videos are posted, where the sections, led by some of the other TFs, are going to be at /sections instead of /projects. So here's what we'll be doing today. Learning a little bit about more dynamic GUIs than what we've seen so far using XML. Learn how to handle bitmaps specifically, and then talk a little bit about the gameplay of NPuzzle and some of the other features you'll need to implement, like saving state and menus and some other things that we haven't seen yet. So far, we've mainly seen GUIs that are built using XML. So we didn't use Java to create buttons. We just wrote XML, and that created button objects, and we loaded them in, and they were displayed. But, of course, that doesn't work well all the time, right? If we don't know what our GUI is going to look like beforehand, we can't really be writing XML to work with that. So in this case, we have a different GUI depending on the difficulty level, right? We could have 9 tiles, we could have 16 tiles, and so there's really no way of hard coding that into the XML. So the way to do that is just to create our UI from Java. So to make sure we have all the things loaded that we need, we make sure to import android.widget. Whatever it is you're going to be using, so buttons or image views or anything else we'll see. Just a small note, if you use the star there, that'll automatically import everything that start with Android and widget. But that will slow down your compilation time a little bit. Technically, probably not enough to notice on a modern machine in a project this size. So here is kind of a mapping from XML to Java. So in XML, we said something like, here's our linear layout, which is just a container of items. And inside of this layout, we've defined a new item called a button. So this will just display a single button on the screen. So if instead of using XML, we instead wanted to create this GUI from Java, such that we don't have to use any XML at all, we can just create kind of the same exact objects. So that linear layout tag in XML translates directly to this linear layout object in Java. So again, this is just the syntax for creating a new Java object. You say the type of the object, the name of what you're going to call that instance of the class, and then you're going to call its constructor. And in this case, both the linear layout and the button are just asking for some context. We can just say this. We just want to send in the current activity to let Android know where this button and layout are created from. So then after we create both our button and the layout, we want to add the button to the layout. Because you'll see here that inside of the linear layout tag, we have that button tag. So it's kind of enclosed within that layout. So to do that, that's not going to happen automatically. So to do that, we're just going to say, OK, I have this layout object now, and I want to add a button to it. So I can just say add this button view, using here the instance of the button, not the button class. So you'll remember that if we start using XML, that we have all these nice numeric unique IDs generated for us. Remember, we can say something like r.id.something, and that something would be what we specified in our XML, and we get back this unique identifier. Using this Java, you can see that that doesn't really apply anymore, and there's no more sense of this unique ID generated for you. So this is something that we need to manage ourselves now. So to do that, we can just say set ID. You can pass in some integer identifier. And this is something that you should be enforcing uniqueness upon yourself. And so that could be something as simple as keeping track of the last ID, and just anything else you create just increments that ID, much as a MySQL database would do, like automatically incrementing something. But of course, this only matters if you need to use this r.id construct, or accessing an element by its ID, which is something you may or may not want to do. But if you do that, remember that Android does expect these guys to be unique within the container that you're searching. So if you're searching within a layout and you have 2 things with the same ID, Android's going to get a little confused because it's only expecting one thing to be there. So just to recap for event handling, so after I create these objects in Java, I now want to attach some event listeners to them. And so in general, we can use this function to assign event handlers to groups of items. So rather than assigning a single event handler to every single item in a list, what we can do is you want to say, OK, I want an event handler to apply to every single item in the list. So then how do I determine what was clicked, for example? Well, that's where this first parameter comes in. It's going to pass in the view that was acted upon. So if I have this onClick listener inside of my activity, and I tap a button, that button is now going to be passed into this method as this parameter. And then I can do things like get the ID of that to determine what it was that was pressed, and so on. And so we'll see an example of that shortly. But some other methods that you might find useful in NPuzzle are just these types of UIs in general. much like we saw in JavaScript with the DOM, we could kind of do things like get parents and get children and get siblings. Well, Android actually has this same notion, right? If I have a view and that view is contained within some parent layout, I can still access that layout by saying something like get parent. And much like the XML, that XML translates nicely, right? I have a button, and that button is enclosed within a linear layout tag, so that parent-child relationship makes a lot of sense. From Java, that parent-child relationship is just expressed through that add view function. So even though we're not using XML and it's really obvious where the parents and children are, we can still access them regardless of whether or not our UI was created in XML or Java. Do you have a question?
Yeah. In this case, the button is a view, it's a one-to-one, or does the view have multiple items in it?
So in this case, so is a button a view? Is that kind of a one-to-one relationship? It is. So a button is basically a subclass of this generic view. So all of the UI components that we'll see are all views, effectively, which is a little different than how iOS handles it, which we'll see. But every button, every layout, or anything like that is just a subclass of this generic view. So that's why this argument to set onClick listener is just this generic superclass view, because it could be anything that was interacted with. So yeah, so by the way, just feel free to interrupt me with questions. I'm happy to answer anything you have. Yeah, awesome.
Can you have part of the layout defined in the XML and some part of it in Java?
Yes, so can you have some part in XML and some part in Java? Absolutely. And this is something that you might want to consider when designing your projects. Things like layouts and containing elements that aren't going to change, you might want to specify in XML, just because it's a little nicer to work with. Like writing all this Java is a little bit annoying and get out of hand really fast. But things that you can't write the XML for, you can certainly still write the Java, even if you have some containing XML, or you can specify the XML for some reusable component and create that with Java, which we'll see a little bit of. But yeah, you can totally mix the two and use design discretion when deciding when to use XML and when to use Java. So just some other methods you might find helpful. You can get the number of children in a layout, so something like the number of items in some row in a table, or you can get the specific child. So if I have a linear layout, and inside of that layout there are 3 buttons, and I know that I want to access the middle button, well, rather than actually needing to access that by ID or needing to have that object, I can just say I want the second child, or because this is 0 index, the child designated with the index 1, I can get the one child from this containing layout to access the button contained within that container. And then we just saw we can add and remove views, which are now subviews effectively of containers or layouts or anything like that, just by simply creating the Java object, then saying add it, you can remove it. And much like we can access a view based on its index in a container, we can also just remove that view. So if I don't have this button object, but I know I want to remove the first one, well, then I can just say remove the view at some given index. Make sense? Question?
The children of a layout, can they also have their own children?
Yes, so the children of a layout, can they also have their own children? Sure. And a lot of times we'll actually see that we can embed layouts within layouts. So you can define something like a linear layout that's going to be horizontal, and then if inside of that horizontal layout you want to have some vertical component, you can have within that linear layout another linear layout that in this case is vertical. So you can go as deep as you want in both XML and Java as far as children, and using these methods you can kind of traverse the structure that you create.
Does the get child count just return the first generation, or does it return all the children?
So the get child count, I believe, should just return the first generation. So let's just take a look at an example of this, because this is still a little bit abstract. So here I just have an Android app with a single activity. These, again, all the source and stuff will be posted online along with the slides. So you'll see here that in this case, I wanted to make sure I have these 2 buttons, and I want them both to have different IDs. So I've just defined these 2 things as constants. So using this Java keyword final, that says that this variable is now a constant. It can never change, and if I try to change it, I'm going to get yelled at. And I see here that I've used all capital letters to designate that this is a constant, just kind of a nice language agnostic style convention. So here, here's my onCreate. I just have a standard layout. It just has a just single linear layout inside of it. And so now, or actually it might have nothing inside of it. So right now, I'm going to create 2 layouts. Very simple, and I'm going to set those IDs to those 2 unique integers I've created. I know they're unique because one's 3 and one's 4, so I don't have to worry about that. And so now I want to add a button to each of these layouts. So here we go. Just creating a new button. I'm setting the text of that button. So much like before, inside of our XML, we set these as attributes. We would say something like Android:text. each of those attributes in XML has a corresponding getter and setter. So if before I were to say Android:text, I'm now saying button.setText. And here I'm just creating two buttons that say button 1 and button 2. And so now you can see that I'm adding one button to one layout and another button to the other layout. And now I'm adding both of those layout to this parent linear layout that I've already created. So this here is how we're kind of mixing this Java and XML. So just to show you, if I open up my main layout here and go to the XML, because I hate that, you'll see that I've already just created this parent linear layout. So I have here already some XML, and I'm adding some components that I created in Java to this layout that's been defined in XML. And because here I have this Android:ID, and I called it root layout, that means that I can access it from Java using the syntax r.id.rootLayout. And so this is a case where this numerical ID is going to be generated to be guaranteed to be unique for me and stored in this special auto-generated class called R that you never really need to touch. So now I want to add an event listener to both of these buttons. So you'll see here that I'm not creating two different methods here. I'm just reusing a single method. So it's a little weird as I'm saying button.setOnClickListener this. So the argument to the setOnClickListener, remember, needs to be some object. So the object that I'm using is this current activity. So that means that somewhere in this activity, I need to define a method called onClickListener, or onClick, sorry. And so that's what I've done down here. So that means that because I've said the event handler for this button is this class, this activity right here, it's going to look for this method called onClick in this very same activity. So what's passed in here is going to be whatever button I've tapped. So here, you can just see we're just going to display the actual text of the button, or the ID of the button. So you've clicked button either 3 or 4 in this case. And then now we're just going to remove it. So now it's a little bit of a dynamic GUI here. So one more thing, because we're dealing with Java, which isn't as dynamic as some other languages like Objective-C, you'll see up here that my class is not only extending activity so that I get all these methods like onCreate and onResume, it's also implementing this view.onClickListener. So as we saw, this is just this is just a Java interface, which says if you want to implement me, you have to provide definitions for the following methods. And by saying that I implement this view.onClickListener, I'm telling everyone else that, hey, I have provided a definition for this method called onClick. So anyone that tries to use this class knows that they can very safely call onClick, and rest assured I have actually implemented that. And by saying this implements view.onClickListener, I'm kind of establishing that guarantee. And if I didn't provide a definition for this method called onClick, then I'm actually going to get yelled at by the compiler, because it's going to say that if I want to implement this, I need to provide a definition. So just to show you what this is going to do, very, very simply, I'm just going to click my first button. It's going to say click button 0, and then it's going to disappear from the view. And same thing here, disappear from the view. Any questions on how I created that GUI and attached the event handler? Yeah?
The term activity you mentioned a few times in there. So an activity represents the screen?
Yes. So an activity is basically this screen here. So in this case, I've just called it walkthrough 1 app 1. And that activity is basically the container for the screen. So when I switch activities, we saw with intents, I'm going to switch from one activity to another activity, which is going to represent effectively one full screen to another full screen.
Where are your intents in this example? Are there any?
So in this example, I'm not using any intents. So the primary use of intents is to switch between screens. But in this example, I just have one screen. And when I created the app, I said that this is the main activity I want you to display first. And so I'm just not using any intents to switch between anything. So now the screen has no buttons. But if we run the app again, or if I close this first, the iOS simulator is much faster. So if I run this again, my buttons are back. It's not like I removed them forever. So any other questions on creating GUIs using Java, or more dynamic ones? OK, so let's move on to something else you'll probably want to use in the project, and that is a list view. So much like the much like many apps use, such as your address book or any list of items, they're probably using this thing in Android called a list view. And all this does is it's literally a view of a list. It just displays some scrollable list of data, and you can define what data is being displayed as well as how that data is being displayed. So that how that data is being displayed is going to be in some layout. So this is probably something you want to create as an XML file, and you're just going to say what you want each row in this list to look like. So in this case, each row is just going to have a simple little text view that's going to display some text. So that's how we display the data. When we want to tell a list view what data to display, we're going to use something called an adapter. So an adapter is basically just some container for some data you specify. So an array adapter is just one type of adapter, and we're going to see these in much more detail in a later section. So this is just a quick overview to get you knowledgeable enough to be dangerous. So we can just create this new container, and what's important is what we're sending in, this list of objects. So this can be an array list, a vector, or whatever you want. Just some collection of objects that you want to be displayed inside of this list view. So if you create, rather than an activity, but a list activity, which again is a subclass of activity, which means it just represents a single screen in your app, if you extend this list activity, you get for free this associated list view. And a list view is going to be the actual UI element that's going to display the list, and associated with that is going to be an adapter, which remember is just what data to display. So if we take a look at one of these other apps, which the numbering is a little out of whack because I numbered them in the order that I thought of them. So this is an example of using this list adapter. So the first thing to notice here is that rather than extending just an activity, we're now extending this list activity. Now, because I want something to occur every time an element is tapped, you notice again we're just implementing this on item click listener, which just again says that I'm going to provide a definition for the method that should be called when I tap an individual element in my list. So just a little bit of boilerplate there. So here I've just defined inside of my strings.xml just an array of strings. In this case, they happen to be baseball teams. So now I'm creating an adapter, which is basically a container for data using this array that I've just hard-coded into my XML file. So to do that, here's my new array adapter. This bracket notation says what's going to be inside of the adapter. Because this is just text, that means everything inside of it is just going to be a string. You could make this an integer or an object or something else if you want. But in this case, we're just displaying text. And so here is what I want to use to display each item. So now if I look inside of my layout XML, so I'm going to go into res, layout, and open up list item, you can see here that this is basically an individual cell in my list, so a single row. And you'll see that all each cell has is just a single text view. And I've done some little things like increase the text size and increase the padding just so it looks a little nicer. And so this I've created to be a single row. And you'll see here that when I create my array adapter, I say I want you to use this definition of a row when you eventually display the list out to the user. And so finally, we want to give our array adapter some data. So this is just something that I've preloaded from my strings file into an array of strings, just right up here. So I've said this is an array of strings. I'm just loading it in from my strings.xml. And now I'm going to say I want my list activity to use this container of data. So by saying set list adapter, this was a method that was given to me for free when I extended list activity. I'm saying I want you to use, as a container, this data. And so now I'm just attaching my event handler to the list view. So this is the actual UI component that's displaying the list. I say, well, every time you want to click it, again, we're going to use this class. And because I've implemented this adaptive view on item click listener, that just means that I provided a definition for on item click, which is basically just going to display the text of the view. So notice here I'm casting it to a text view, which means that I suddenly have this method getText. So just this generic view doesn't have a method called getText. But I know that everything being tapped is going to be a text view. And so I can just say, I want you to make this a text view and get the text of it. So if we run this, all this setup and boilerplate and abstraction for something a little underwhelming, but I get something like this. So here is just my list of data. It's scrollable, and every time that I tap a list, it's just going to display the contents of the cell. Yeah?
If you wanted to associate pictures with those things, would you, in that XML file, instead of just having text view boxes, could you add like a, I don't know what it's called, but the image view thing?
Yeah, so let's say that instead of just this text, you now want to have images. So this is something we'll cover a little more in another section. But basically, yeah, you're definitely on the right track. You want to modify this cell to now have an image view. You're also going to want to pass this data to your adapter somehow, so that your adapter can tell the cell what to display. So more on that later. This was just a quick overview. But this is just how to display a very simple list. Yeah?
And these strings are returned in no particular order, right? It's just random.
So these strings are written in the order that I've defined them, which just happens to be here in my strings.xml. So I've just say I have a string array here. I called it teams so that I can access it later using getStringArray teams. And now here's just a list of items. And so they'll be displayed in the order they appear here. Other questions? Yeah?
Sorry. The question is on adapter view.
Mm-hmm.
You're extending adapter view versus the last time you were extending view dot.
So in which section? Yeah.
Implements adapter view.
Yeah. So last time I'm just implementing the onClick method. And so when I'm working with list views, instead of onClick, I'm now working with this onItemClick. So these are just two separate methods. So rather than just like generic click, we're specifying the event for clicking a row in one of these scrollable lists.
Okay, and then a second question is, how do you tell it which way you want it to go, vertically or horizontally, or does this list activity have a horizontal?
So this list activity, I believe, only does this vertical list. There's probably another layout that you'd want to use to make it horizontal. But there are certainly things that you can do, like extend the list activity and modify how it's displaying your data, which we'll again see in a later section. We want to display more than just a line of text. But you could effectively make it yourself horizontal. Out of the box, it's just going to be vertical like this.
One last question.
Sure.
Can you explain the concept of adapter again? So adapter is the data that gets supplied to that activity, is that right?
Exactly. So the adapter is just where where this list view here is getting its data. So instead of just passing this, an array of strings, we're actually going to pass it something that tells the list view how the data will be displayed. And this array adapter is just a class that's already been written for me that just says, well, I want there to be a single text view, and whatever data you're going to pass me a bunch of strings, and for every string that you pass me, I'm going to create a new row. So we'll definitely see more complex examples in a later section. But you can basically extend adapters to make them do whatever you want. And this is just kind of the nice off-the-shelf adapter that displays strings. OK. So that's list views. So one of the first things that you'll want to be doing with this project is taking that image that the user has determined to be the puzzle image and breaking it up into a set of tiles. And so the first time I approached this project, I thought it would be really helpful to just Google it. And I Googled Android breakup image, and I, of course, got something like this, which made me really sad. So don't Google Android breakup image if you're not prepared for something like that. So just a review of the spec here, we have to be able to create a background from a variety of images. So we're not going to guarantee you, and we can't really guarantee you, that the image is going to be the same size as the device. Because we're dealing with Android and there are a bunch of different devices, there are, as a result, a bunch of different screen sizes. And so your app needs to take into account images that are smaller, that are either in portrait or landscape orientation, and kind of resize them accordingly. So, not to worry, it's not that complicated to actually resize and crop images like this. So we're going to be working in Android with this class called bitmap. And this bitmap class can work with images that are defined in res/drawable, which is something that the spec mentions. It's just where we can put all of our asset files, or basically things that we want to be drawn to the screen, or bitmap images, really. So in order to access some image that's stored in the folder res/drawable, which you can just add to our Eclipse project or just put it there, we're going to use this design pattern in Java called the factory pattern, where we have this special class called bitmap factory. And the purpose of this class is to take some resource identifier or something inside of res drawable and load it into memory into a bitmap that can then be displayed to the screen. So the two arguments here are just going to be where the resources are coming from, which is just, you can just say get resources because that's where resources are coming from. And then next, it's going to be the ID of the image you want to draw. So I can just specify basically what I've called the image. So that's going to take the image and load it into memory. It's not going to display it on the screen yet. It's just going to create this internal bitmap object that represents an image. So now, the images that we load in, as we just said, are probably not going to immediately fit the screen. And if you want to start breaking up the images into tiles, you obviously don't just want to load the entire image 16 times. You want to only load basically cropped versions of that. So in order to do that, we can use this nice method called create scaled bitmap. And what this does is it's going to take as an argument one of these bitmap objects, or this internal representation of an image, and then you can ask it, well, I want the width and the height to be whatever I want, which in this case could be something that you specify as a function of the screen size. So the screen size can just really easily come from this method getDisplayMetrics, which will just return to you the screen size in pixels of the width and the height. So the first thing you probably want to do with your image, or if you want to do this, is resize it. So this takes some image that is n by n pixels, and you can make it m by some other thing pixels. Basically, scale and transform it in any way that you want. So after you've resized it, you need to make sure, however, that you are maintaining the aspect ratio. So if you know as little about photography as I do, the aspect ratio is basically the ratio of the width to the height. So this is equivalent to, if you've ever put an image into Word and you've dragged it along the diagonal, you notice that it didn't really become distorted. Just the width and the height changed at the same rate. And so in order to do that, you need to modify the width and the height by different amounts. So when you are creating this scaled bitmap, you can't just say, well, I want this to now be 100 by 100 or be the exact width of the screen, because your aspect ratio is no longer going to be maintained. So now, if you want to start cropping your image, we have this other handy function called createBitmap. And this, again, is going to take some internal representation of an image, which could be something that you just scaled, or it could be your original image. And now we can start breaking it up. It's going to take as arguments now, instead of the width of the height, and in addition to, the width and the height, where you want to start cropping from. So if I want to start cropping from, say, the middle of the image, I might want to specify as the x and y something like 100, 100, because 0, 0 is going to be in the top left corner. So if I want to cut out kind of the top left portion of the image, I can specify some x and y, and then specify the width and the height to basically take some larger image and create a smaller image from it. So let me show you a quick code example to make that make a little more sense. So we're coming into here. OK. So here, inside of my res drawable, you'll see that I just have this image, puzzle0.jpg, and that's the format of the file name that we're going to be giving you images in. So the first thing I'm going to do is take this image and load it into memory. So I'm going to say bitmap, I'm just calling it background. I'm going to use this decode resource and say that I want the image called puzzle_0. So you don't have to worry about the .jpg or the .ping, but just the name of the file is going to be how you access it from res/drawable. So now I have this internal representation of a bitmap. So from that large bitmap, I now want to crop it. So the arguments in order are going to be the x and the y, and then the width and the height. So if I start from 0, 0, that means I'm going to start at the very top left of the image. And so now I'm slicing off a little portion that's 100 pixels by 100 pixels, which is equivalently kind of the top left of my image. So this is going to return to me another bitmap. So because I now have this smaller bitmap, and that's what I'm going to be displaying, I don't need that larger bitmap. And because these devices don't have a lot of memory, you probably just want to jettison that from RAM. And to do that, you can just say recycle on this original bitmap. So by saying recycle, I'm saying, all right, I can now remove this from memory. I'm never going to access this again. And if you try to access this again, that's going to be a problem. OK, so now I have this internal representation of a cropped image. So in order to actually display it to the user, I want to use the image view, which, just like a button, is a subclass of this generic view. And to do that, I'm going to say set image bitmap, and that's going to be the image that is displayed by the image view. And I want to display this cropped image. So this is, again, it's just a bitmap object. So the set image bitmap is just expecting any bitmap object, whether that be something you loaded directly or something you loaded and then manipulated. And then I'm just going to add it to my layout. And I'm saying that I just want to add in this image view here into this root layout, or just this containing layout that I've defined inside of my XML. And then just down here for fun, I'm just going to output to the user the width of the screen. So just get resources, get display metrics, and width pixels, and that's just going to be the width of my screen. I'm just kind of displaying that in a toast here. So one thing to note, as I mentioned, these devices have very little RAM, and so it could very well be the case that if you load big enough images, you run out of RAM. And so it's a really good idea to start surrounding all of this image loading code in try-catch blocks. So this is Java's method of error handling. So inside of this try statement is going to be everything that Java is going to try to do. And inside of this block, it could very well encounter an exception or an error that will effectively prevent it from continuing. So if in any of these statements, which probably will be either decode resource or create bitmap, because that's what's loading new things into memory, if it so happens that it now runs out of memory trying to do doing one of these things, your code is going to jump down here into this catch block. And you probably want to do something other than make a comment to yourself to do something here. Whether that just be display a message to the user or effectively prevent your app from crashing. And so in this case, we're catching a specific error, which again are just classes. So I'm catching this out-of-memory error, which is nicely named. I could also catch more generic errors by just saying exception or error or what have you. But in this case, this block is going to fire when my device runs out of memory. Question?
Normally you can catch exceptions, but here you say error. Can you recover from an error? I mean, in Java, you have these exceptions and errors. Normally you can catch exceptions and then do something and recover, but errors are you can't recover from them, right?
So in this case, this out-of-memory error is just something that Android has named the class. So by reaching this block, if we just kind of get rid of that bitmap, then we should be able to prevent ourselves from crashing. But if it comes the case that your app crashes, but it's clear to UTF that you're trying to catch this error, we're not gonna yell at you for that. But it is important to realize the physical constraints of these devices. This isn't my nice MacBook Air with 4 gigs of RAM that won't have trouble loading an image into memory. These are very small devices with between 256 and 512, maybe a gig if you really buy a nice phone, of RAM that might not be able to load into memory all of these images. So just something to keep in mind. So if I run this, you're going to see here that for my large image, I've just basically taken the Extension School logo. You can see here that I'm now only displaying the top left corner. And this is a square image because I've set 100 by 100, and I've just created an image view, added it to my layout, and added this bitmap to that image view, and therefore displayed it. So just to recap, the functions you care about are decode resource. Decode resource takes an image that's stored as a JPEG or a PNG, loads it into memory in a format that Android can then deal with. If you want to change the size of that image without cropping it, so basically take something that's 200 by 200 and reduce the size of that to 100 by 100 or what have you, you're going to use create scaled bitmap. And once you want to crop it or make little tiles from an image, you're going to use just create bitmap, which isn't going to scale it, but basically cut it up into pieces. Question?
Is there an overload which takes floats or doubles instead of pins?
I'm sorry?
Is there an overload which takes float or double instead of pin?
So I think we're only dealing with ints just because we can't go sub-pixel levels. So this will basically create an image that in pixel size. So we can't deal with fractional pixels, so that's why everything's an int. Other questions on dealing with images? Yeah?
It seems to me that if you use the X and Y you passed in starting from 0, 0, it wouldn't be very effective. Because how do you know what you're going to get by 100? There must be a better way to do it, right?
So in what sense?
Well, you're not going to know what you're going to get if you pass in 100 and 100 as your X and your Y. There must be a better way to chop up your image, I guess.
Sure. So how are we chopping up the image? So keep in mind that we know the size of our screen. And so if we know that we want to create 3 tiles, and because we know the size of the screen, we can also get the size of our image similarly. And if we know that we want 3 columns, then we can say, OK, I want the total width of the image, and I'm going to chop it off divide that by 3. And so that's going to give me 3 numbers, basically. I have the starting at 0 to that first cutoff, starting at the first cutoff to that second cutoff, and then from the second cutoff to the end of the image. So those are numbers that you're not going to hard code, but you're going to dynamically determine based on the number of slices you want to make and the total width of the image, if that makes sense. Yeah, but just for this demo, I just happened to know that my image was larger than 100, and so I didn't run into any errors. But you'll probably want to pass in some calculated value, unless you're just kind of testing things out. OK. So now let's move on to the actual gameplay of NPuzzle. So just before we do that, some other handy methods you might want to think about using. So every view object can have what's called a tag associated with it. And a tag is basically some generic container for data. So this is a way of effectively associating some metadata with some view. So if I want to keep track of where the view is displayed on the screen, I want to associate some x and some y with that. That x and y, those properties, aren't normally associated with the view, right? They're not built into the view class. But I still want the view to be able to contain that data. So that's where I'm going to use a tag. So I'm going to say I'm going to create some object, create some class first called container or tile or image or whatever you want to call it, and create properties for anything you want to store. So if I'm just storing x and y, it'll have 2 integers, one x and one y. So now if I want to associate some data with an image, which is just a view, I can say set tag and create an instance of this container data class. So I can create this data class, which I'll call tile, say tile.x is 0, tile.y is 5, and then I can say, whether that be an image view or something, set tag and pass in this data. So now, once I'm dealing with views and event handlers, if I want to get that data associated with a view, I can just say get tag. And that's going to return to me back that object that here just has an x and a y, and I can basically read out that data that I've associated with an image. Does that make sense? So basically just ways of associating more data than I normally would with a view. So views don't have all the properties that I want to store. I just want to create some more. I'm going to create a tag, which is just any object I want, and associate that object with the view. So this is the game that you'll be playing. This is the image taken from the spec. I've taught this for I don't know how many times now, and I still can't solve the game of 15. So after making this Android app, if you find that you still can't do it, don't worry, because I'm terrible at it. So in the board, we're going to have basically an n-by-n grid. So there's going to be one blank tile, so that we have the ability to shuffle tiles around. And every other tile here has a number associated with it. So in your case, you're going to have images associated with it. So we want to create, perhaps, some kind of internal representation of our board. Maybe using an array or some other container that you want. And then you're going to quickly run into design decisions like how do you want to represent the board? If I want to get the column in the tile in row 2, column 1, do I want to say XY? Do I want to say row column? These are just some of the design decisions that you might run into kind of immediately. So inside of the board, we probably want to represent tiles. So here again is another opportunity for good software design. You want to first think about all the information that you want to associate with the tile. So things I mentioned before, like its x and y position in terms of row column or the traditional xy or column row. And you also probably want to associate it with a number, right? The game of 15 uses numbers, and the way that we know it's solved is when all of the numbers are increasing order. Now, we're not asking you to write any image detection algorithms to try to figure out when the image is in order. But basically, if we simply associate with each tile and subsequently each cropped image a number, then we can start dealing with that to determine both how to set up the board in its initial state and determine when the board is 1. So it's a really good idea to encapsulate that information, and then it's up to you basically how to associate that information with each of your tiles, whether that be some internal representation of the board or using tags somehow. It's totally up to you. So these are just a few of the design decisions you'll see. And, yeah?
Tile object, or can you have something that says tile data would be your object?
So in general, tags work with any object you want. So you can create any object and associate that object with the view. So if you want to create your own class for tile data and associate that class with the view, the tag would be one way of doing that, if that makes sense. So a special case here is going to be the blank, right? We don't want to do something like, confuse the blank tile with the tile number 2 or tile that's the top left corner of your original image, because that's going to effectively prevent us from playing the game. So how you represent the blank tile is another design decision. Is this a new class? Does this have some sentinel value? It's up to you how to represent the blank tile. But one thing to think about is that this blank tile is probably the most important tile on the board, right? Every time that you try to make a move, the first thing you need to do is check if you're next to a blank tile. So doing things like searching the entire board, like where's the blank tile, might not be the most efficient operation. So another design consideration might be, how can I make sure that it's really easy to access the blank tile, but how can I also make sure that I'm not wasting a ton of space by how I'm keeping track of this blank tile. So up to you how you do that, and just something to take into consideration. So in order to construct the board, we have a few options for layouts. So if you look at the Android documentation, you'll see these are their 3 most commonly used layouts. So in particular, let's take a look at the table layout. And you may have seen in developing mobile local HTML tables, which basically just define, as a regular table that represents like a table associated with the chart that just has rows and columns. Not the table that you eat dinner on. But basically, we're defining a set of rows and columns. So to do that, we're going to say in our XML some table layout. That's going to be the containing class. And then that table layout is going to have table rows. And each of those rows is going to define a new row. And then all of the elements that you put inside of that table row are effectively going to serve as columns. So in this case, if we look at this, so and that's not, oh, here we go. So here, I'm just using a table layout. So rather than starting off with a linear layout, as we've seen in the other examples, we're now starting off with a table layout. And this is kind of the topmost element inside of our activity. So inside of here, we have a few table rows. So you notice here that each of the table rows has the same number of children. Because inside of our table, we probably want each row to have the same number of columns. So each of these children here is just a generic text view that's going to display some text. And so we've just associated here some text and some padding. And so what our table layout is going to do is display these things one next to another. So first, we'll see this, and then next to this, that's now right aligned because I've set the gravity to be right. It's going to be the text is. So we'll see something that looks like this. So here you can kind of see the table structure. Here's my first table row, and I have 2 columns effectively. Here's one column, and here's another column. So in addition to just text views, you can also display other UI elements. So here's a button, here's a text field, also displayed in our table. Does that make sense to everyone, how that's working? OK. So another option that you might want to take a look at, in addition to using a table layout, might be this other UI control called a grid view. And a grid view is very similar to the list view that we took a look at earlier, and that it's going to have an adapter that's going to be the container of data that it's going to display. And it's also going to have the same event handler that on item click, so on clicking each of the items, you're going to be implementing it the same way as you would a list view. And rather than displaying things simply in that vertical list of cells, it's going to display them in a grid. And when you create the grid view, you can specify the properties of this grid in terms of rows and columns. So definitely check out the documentation for more specific information. But using that, you can also effectively construct some board. So it's up to you if you want to use either of these methods, or you could even use linear layouts, right? You could have a horizontal linear layout that contains cells and have all of those contained in a vertical linear layout, so you can kind of emulate the grid using that. Or you can look at table layout, grid view, or plenty of other Android controls that are capable of displaying collections of items. So those are just the few that you might immediately want to look at. So now let's take a look at how we're going to swap tiles. So the game says that the tile should be swapped if and only if it's next to an empty tile. So two numerical tiles that are next to each other shouldn't do anything when I tap either one of them. And you can also make sure to check corner cases like swapping a tile off the board, which is pretty unfortunate and hard to recover from. And making sure that not only do the images change in your visual representation of the board, but those elements also change in however you're representing the state of the board internally. So your basic process is going to be, I want to know what the tile I just tapped is. I want to know where that is on the board. I also want to know where the empty tile is on the board. And then I want to see if they're adjacent. So they could be, I basically want to check from the tile I tapped, up, down, left, and right. But keep in mind that checking each of these cases individually might be a lot of copy-paste, which we've said isn't really the best design in the world. So maybe you want to think about a way to kind of factor out this check and avoid a bunch of copy-paste statements to determine if two tiles are adjacent. So visually swapping tiles, we said that this image view that we saw in the bitmap example is what's going to actually display an image. And you can use a bitmap, which is an internal representation, or a drawable, which is just something that's stored in that res drawable folder. So we can actually dynamically change the image that's displayed inside of the image view. So if we just call one of these methods, I can effectively replace what image is being displayed by this image view container. Or I can actually physically move the image views, right? I can just change their position in my layout or grid view or however I specified it, and I can just change the position of two tiles to physically move. So which of these methods you choose for swapping tiles is up to you, but know that there's more than one way to do this, just like there's more than one way to represent the board. Question?
Sorry, that went by too fast.
Sure.
Yeah.
Yeah, so basically the image view is maybe the container you're using to actually display the image. Right, so we said in the bitmap example, we used this method setImageBitmap. And that's going to say what the internal representation of the image you want to represent is actually displayed on the screen.
Or say like a section of your grid.
Yeah, exactly. So this could be an image view could be one tile, basically. So now this setImageBitmap isn't just something that you can call once, but it's something you can call dynamically. So you can say, I want an image view that was displaying this tile. I can say, OK, I now want you to display this tile. So that's one way. Or you could also actually move it. Right? So you can change the position of image views such that they actually swap. So there's just more than one way of swapping tiles on the game board. Another question?
Can you attach an event handler to that image view?
So can you attach an event handler to the image view? Yes. So just like we attach an event handler to a button, we can attach it to an image view that's displayed in a linear layout or a table layout. And we also saw that the grid view specifies, just like the grid view, just like the list view, specifies that event handler for on item click. So depending on your container element for all these tiles, you're going to probably want to use a different event handler, if that makes sense. OK. So now, after you've taken care of swapping tiles, you'll probably want to work on the method that determines when the board is solved. So in our case, the game is won when you've fully reconstructed the original image. But in terms of the game of 15, that's just equivalent to the tiles being arranged in increasing order. So if any tile is not in increasing order, that means that there's no way that the game can be won. So when the game is won, you'll want to display some congratulatory message. And remember that these intent objects, which are just containers that specify where you want to go, to what activity you want to go, and maybe some data along with it, and these intent objects are what are used to switch between activities. So any questions overall on gameplay or how to implement anything there? Oh, yeah.
So on click, you have to implement that because it's specified in the interface, but could you also overwrite and create your own on-click with different parameters, for example?
So could you also create your own on-click with different parameters? So not directly, because this on-click is going to be a callback that Android is calling for you. What you could do is have your on-click method just call some other method that you wrote and pass in any additional parameters. So maybe you'll just define some other method to actually do the event handling. rather than just putting it all inside of onClick. But because this is something that Android is calling, you can't really modify its signature. Other questions? OK. So let's really quickly, let's look at how to save the state of the board, which is another feature. So things that the spec says you should be saving is the state of the board, the number of moves that have been made, the difficulty, basically everything that you'll need in order to restore the state of your gameplay from when the user locks the device or hits the home button or something like that. So remember the activity lifecycle that we took a look at in an earlier section. On pause is going to be called when the activity is removed from the foreground state. So this might be a good place to actually determine what values you want to save and actually save those. And on create is going to be called when the view is about to be set up. So this is one place that you might want to start looking at state retrieval and resetting the state to where it was before. And on resume is going to be called before the activity is put into the foreground state. So again, this might be somewhere else that you want to take a look at restoring data to the view. So when you're dealing with each of these activity methods, don't forget to call the super method. The super.onPause or super.onResume, because your app is very likely going to crash if you forget that. And in each of the cases that we've seen so far, when I implement my own onCreate method, you'll see the first thing that the template code does for you is say super.onCreate. That's so that we make sure we do what the activity needs to do when it's created, and then we can start doing what we need to do when the activity is created. So very easy to forget that once you start dealing with methods that aren't simply onCreate. So in order to save and retrieve state, we're going to use this special object called shared preferences. And basically what this is going to do is allow you to store key value pairs, where the value is specified in the documentation. There's different methods for each type. The value can be something like a Boolean, a string, an integer, etc. And so basically this is the equivalent of storing a hash map or an associative array, where it's up to you to determine in what format you want to store the board data and everything else you need to restore it. So just like there are a series of get methods, there are also a series of put methods, this time using a special object, the shared preference editor. So the shared preferences object is going to retrieve state, but the shared preferences.editor is going to be the object we're going to invoke to save state. So to save these key value pairs, all of those get methods, like I said, just have a corresponding put method, where I can save some key value pair, specify just the string key, and then the value can be an integer, a string, a Boolean, etc. Now to actually write these changes, you're going to call this commit method, which says that anything that you've put since the last time you committed is now going to be stored to disk. So let's just take a quick look at this example. 1, 2, 3, 4. So here, you'll see that on resume, here I'm just retrieving state. So I'm saying, using this shared preferences object, I'm saying get the preferences. And from that preferences, I'm going to get an integer, because I'm saying get int, which means that the expected type of the value I'm retrieving from the storage is going to be an integer. And the key I've stored it in is just arbitrarily the string chars. So the second argument to get is going to be the value that's returned if this key is null. So if I actually haven't saved something in a key called chars, rather than throwing an error or returning null or something, this method is going to return this second argument. So basically, that's how you would want to implement your error checking there. So then here, I've just make sure you don't forget to call super.onResume. And so now, when I save the state, notice here that I'm now working with the editor rather than the preferences object. And this is just the interesting syntax of getting that error. It's just getting that object, which is just a property of this shared preferences object. Basically, you can see now, instead of getting an int, I'm now putting an int, or saving something into this state object. So I'm saving it under this key chars, which matches the key up here. And now in this case, I'm just saving the number of characters that the user has entered into some text box. So feel free to run this on your own. In the interest of time, I won't. But again, don't forget to be calling all of your super methods so that your app doesn't crash.
Why are you calling those at the end and not the beginning?
Yeah, so in this case, it doesn't happen to matter. I could just as easily move these to the beginning. Other questions? Okay. So feel free to run that on your own, but basically it's just kind of a lot of words to basically get some object that is responsible for storing data to the disk and getting data from the device's disk, which will always be in key value pairs. So the final element that we haven't looked at yet, but we will shortly, is menus. So the app specifies that you need to be able, the spec says that you need to be able to press the menu button and have some options appear. And the way to do that is by using Android's menu resources. So menus are going to go into this special folder, res/menu. Just like we have the values folder and the layouts folder, there's one just for menus. And menus, just like all of our layouts, are going to be XML files. And you're going to define some top-level menu element that's going to have multiple children that are specified as item elements. And so here are just a few of the event handlers you might want to see. Take a look at. The first one is called when the user wants to display the menu, and you can just take control of which menu you want to be displayed. So when the user presses the physical menu button, what menu do you want your app to display? And the second method here, this on options item selected, is the callback that's going to be fired when the user selects some menu item. And much like the event handlers we saw earlier, this on click and this on item click, you're basically going to attach this event handler not to individual menu items, but to the entire menu itself. So that's why we're passing in as a parameter the item that was actually tapped. And again, we can use the ID or any other property we want in order to determine what it was the user actually tapped. So let's just take a quick look at this menu example. So first, let's take a look at res menu. So this is just a folder I had to create. Now my options menu has at the top level this menu element, which says that what's coming next is going to be a menu and a list of items. So now I just have a series of items. Each of these items has its own text. You'll see here, this is the interesting syntax for using Android's built-in icons. You can kind of Google around for online icon explorers that display all of the different icons on the device. But basically, these images are built into the device, and I can access them with this @Android drawable and then specify basically the identifier for each of these icons. So you can Google around for what identifiers match up with what pictures. But now, you'll see here that I've defined a couple of new methods. So again, this onCreateOptions menu was defined by the activity class, and I want to override it and do something else. So in order to display a menu, I'm going to use this special object called the menu inflator, which basically all that's going to do is take some XML that I've defined my menu in and display it to the user. So load all of that into memory and then display it. So just really simple, I'm going to say inflate, and I want to tell inflate where the menu is coming from. Because I've called my file optionsmenu.xml, and I've put it inside of the res/menu folder, I'm going to say r.menu.optionsmenu to return the unique identifier for that menu. And then I just want to pass in this menu parameter here, which tells Android where to display the menu, just whatever was passed in here. And so now after displaying the menu, I want to take a look at handling when someone taps an item. So here, you could use a case switch statement here. You could use a series of ifs and else ifs. But just like that button example before, we're going to say, all right, well, I want to look at the item ID of what was tapped, or the unique identifier for that. And if that's the same as the first option, then I'm going to take some action. Or if it's the same as the second option, which remember, both of those have unique IDs that I've specified here. So this first option has the ID option 1. So when I say r.id.option1, I'm now effectively referring to that item XML element. And I can compare those two numerical values just with the regular equality operator. And then I can just display some message to the user. So it's important also to return true here. That return true tells the system that you actually want the menu to be displayed. If you were to return false here, that would basically prevent any menu from being displayed. And you can do the same for the back button. So we fire this up. You can see here that on the simulator, this is the 2.1 simulator. If I just click on this menu button, you'll see down here that this is the menu that I just created. Android takes care of arranging these items. Like that 2 on the top, 3 on the bottom is not something that I specified, but it's something that's built into Android. And if I just give it 5 menu options, that's what it's going to do. And if I click on one of these menu items, the appropriate action is going to be taken. OK, so does anyone have any questions, by the way, on the problem set, menus, anything at all regarding NPuzzle? Yeah?
Yeah, just out of curiosity, is the difficulty levels, is a better approach that it's kind of like a dynamic thing or more of a preset?
So the difficulty levels are the better approach dynamically or as a preset? So in what sense?
In terms of how you build them and construct them, the number of grids.
Sure. So we know that we only have to specify a finite number of difficulty levels, and each of those has an associated number of tiles in a single row. So you probably want to do is create some mapping between easy and 3 tiles per row, medium and 4 tiles per row. So how you construct that mapping is up to you. But you could very easily just hard code easy, medium, and hard, and that would be OK because we're not ever asking you to support more than that. But when you break up the image and how you create those tiles, that is something you probably want to design to be dynamic. So just have the equivalent of some method that takes in a difficulty level, or have some way of passing a difficulty level to some constructing method that, based on the difficulty, knows how many tiles to construct. So having something like create board for easy, create board for medium might not be the best design, because that'll be a lot of copy-paste. But that mapping between easy and 3 tiles could be something that's just hard-coded, because we're not expecting you to do any more than that. Does that make sense?
Just thinking in terms of the layout, the view.
Yeah, so so I would say definitely design your methods such that it's very easy to display a board of any arbitrary number of breaks, right? So I can say, if I wanted to say break up the board into 6 tiles per row, I don't have to. If your method is designed to basically take that parameter of how to break up the board, that would be possible. And what you're passing into that is some mapping that you can hard code between easy and 3. So when you're actually constructing the board, I would definitely say to try to make that method as flexible and dynamic as possible. Because maybe in the future, your boss could come and say, I want a super hard that has 5 per row, even though we're not going to be doing that. And we're not going to ask you to allow the user to create a new difficulty level or edit those preferences at all. Other questions? OK, so I'll be posting all the source code online. To actually bring it into Eclipse, you can just go to File, Import, and then Existing Projects from Workspace. Make sure you've just created an AVD, if you haven't already, for 2.1, which all of these should be targeting. So if I fire up this guy here, the Android Virtual Device Manager, just want to make sure that I have one with a target of 2.1, which is the minimum version that the spec asks you to support. So that's just the version I use for these examples. You might get a weird error like target not found if you don't have one that matches. So just a heads up on that. Thanks.